In this video, we are going to see about tutorials based on the classification of discrete time signals. First classification is energy signals and power signals. The example we are going to discuss here is if a signal x of n is equal to 1 by 2 power n into u of n is an energy signal or power signal. The solution for this example is solved here. We know that energy of the signal x of n is given by E is equal to summation n is equal to minus infinity to infinity modulus of x of n the whole square. In this step, we are going to include the value of x of n. In the question, it is given as x of n is equal to 1 by 2 the whole power n into u of n. We know that u of n is a unit step sequence where u of n is equal to 1 when n is greater than or equal to 0. 0 for the negative values of n. U of n is valid when n is greater than or equal to 0. So, instead of taking the summation from minus infinity to infinity, here we can take from 0 to infinity 1 by 2 power n the whole square. Now we can write summation n is equal to 0 to infinity 1 by 2 power 2n. In this step, 1 by 2 power 2n is written as 1 by 4 power n. We know that the series expansion summation n equal to 0 to infinity a power n which is equal to 1 by 1 minus a, where modulus of a is less than 1. If you are using the series expansion summation n equal to 0 to infinity 1 by 4 power n which is equal to 1 by 1 minus 1 by 4 which is equal to 1 by 3 by 4. Again it is equal to 4 by 3 which is a finite value. Here the energy is finite, so we can call this discrete time signal x of n as a energy signal. Now we can determine the power of the signal, which is given by p is equal to limit n tends to infinity 1 by 2n plus 1 summation n equal to minus n to n modulus of x of n the whole square. In this step, we are going to take in the place of x of n which is equal to 1 by 2 power n into u of n. We know that unit step sequence is having the values when n is greater than or equal to 0. 0 for the negative values of n. Because of unit step sequence, we are taking the summation n is equal to minus n to n as summation 0 to n. In this step, the summation n equal to 0 to n modulus of 1 by 2 power n the whole square is rewritten as summation n equal to 0 to n 1 by 4 power n. We know that the series expansion summation n equal to 0 to n minus 1 a power n which is equal to 1 minus a power n divided by 1 minus a. In this problem, we are having the summation from n equal to 0 to n instead of 0 to n minus 1. So, the series can be written as summation n equal to 0 to n a power n which is equal to 1 minus a power n plus 1 by 1 minus a. So, in the power of the signal, summation n equal to 0 to n 1 by 4 power n is rewritten as 1 minus 1 by 4 the whole power n plus 1 divided by 1 minus 1 by 4. Solving this, power of the signal is equal to limit n tends to infinity 1 by 2n plus 1 into 1 minus 1 by 4 the whole power n plus 1 divided by 3 by 4. When you are applying the limit n tends to infinity, the above term is changed to 1 by infinity, which is equal to 0. Therefore, energy E is equal to 4 by 3 and power P is equal to 0. Since energy is finite and power is 0, the signal is called as energy signal. Students can determine the signal U of n plus 2 minus U of n minus 2 is a energy signal or power signal.